Alright, so we are dividing rationals here. This is the last piece to these, and it is almost exactly the same as multiplying them. It just has one extra little step at the beginning. So, we are dividing. So this little symbol, you got to take care of whether if it's a multiplication or a division symbol, because when it's division, if you remember with dividing fractions, you flip the second fraction. Okay, so I'm going to rewrite this. I got 5 over my 10n squared. First one always stays the same. And then it's going to change it into multiplication when I flip these around. So my 10n squared goes on the top, my n minus 1, and then my n plus 1 with my n minus 1 go on the bottom. And then it's the same deal that we were doing last time. We're crossing things out. Anything from the top that's identical with anything from the bottom gets crossed off, and whatever is left over here is what becomes our answer. So our answer, we have a 5 in the numerator, and we have n plus 1 in the denominator. Okay? Not too bad. Let's try if it's not already factored. So same deal. First thing we're going to have to do is take this guy and flip this one around. So I'm going to keep this b squared. That's going to drive me crazy. Squared. Minus 5b plus 4 over 4. That stays the same. This changes into multiplication. And we get a b plus 6 in the top now. And we have b squared plus 2b minus 24. Okay, and then we're going to factor these just like we did before. So I need to find numbers for this first one that multiply to give me 4 but add up to give me a negative 5. So I got a b and a b here. And 4 and 5. So 4 and 1 give me a 5, and if they're both negative, then negative 4 minus 1 is negative 5. Negative 4 times negative 1 gives me a positive 4. Okay. This 4 right here will stay the same. This b plus 6 will stay the same. Sometimes I think it's helpful to throw it in parentheses just so that it looks like the other ones. Sometimes it's hard to see them to factor if you don't do that. Alrighty. And then in this one, we need two numbers that multiply to give me a negative 24 and add up to give me 2. Take a second, think, ponder, wonder. Hopefully you realize that 6 and 2 fit the bill. And 6 will need to be, not 6 and 4. What are you doing, Miss Holly? This needs to be 4. Get out of here with that. So we'll get a positive 6 and a negative 4. And then we're going to cancel out, same deal. This guy knocks out with this guy. This guy can knock out this guy over here. And we end up having b minus 1 over 4 as our answer. And then in our last problem, exactly the same deal. Okay. So we're going to change this into multiplication by flipping this fraction around. So my n minus 2 stays here. N squared plus n minus 42 goes here. Now I got multiplication. Top becomes n squared plus n minus 42. Bottom becomes n squared plus 7n minus 18. If you pay attention, yes, we could go through and we could factor this guy and we could factor this guy. But do you notice that they're exactly the same already? If that happens, you can automatically cross them out. You don't even have to factor them. Hot diggity. All right? So then we just have to factor this guy and see what beautifulness it will leave us with. So I got n and n. Multiply to get me a negative 18. Add up to get me a 7. So let's see. 9 times 2 is 18. That'll definitely work to give me a 7. 9 and 2, I need a positive 7, so I need a positive 9. And let's just double check that real quick. Positive 9 minus 2 is 7. positive 9 times negative 2, negative 18. Yep, that works. Beautiful. So, what can we cross off? Ooh, we can look negative 2, n minus 2, n minus 2. So I only have this guy left, this n plus 9, but n plus 9 is in the denominator, which means we got to throw a 1 up top, right? Because when you cancel things out from the top and from the bottom, you're actually dividing them by themselves. They're turning into 1, so a 1 exists there. We just don't normally write it because it's normally multiplied by something else. But there you go.